Hi again, Algebra Troops. Last lesson in Chapter 6 we're going to talk about today solving equations by factoring. And if you've wondered why in the world we even do factoring, after all, last chapter we were doing the opposite, in other words, multiplying binomials and other polynomials together. In this chapter we're breaking them apart into factors. Well, here's the biggest reason today. I would say the biggest reason we need to learn about factoring is in order to solve certain equations. There are several types of equations, especially ones we call quadratic equations, where it's extremely helpful to be able to know how to factor, and we'll see several examples of that today. But here's the key idea here, the zero product property. So if you have two things that are multiplied together and they equal zero, A and B in this case, we know for sure that either A has to be 0 or B has to be 0, or perhaps both. I forgot to put an A in there, hopefully nobody saw that, but both A and B should equal 0. So that's huge, the zero product property, and we'll see that. We're just going to get right to several examples here and get these down in your notes, and that should help you out quite a bit. So here's our first example. Notice this is something that's in factored form already. We have this times this equaling 0. And what this means, just from this zero product property, for sure this means then that, I have a narrow pen for some reason there. Alright, I'm going to that. This means that either x plus 3 has to equal 0, or x minus 5 has to equal 0. That zero property tells us that. Well, we can obviously tell here then that either x is going to be negative 3 or x is going to be 5. So this is a real basic aspect of the problem here. We'll always be trying to get our equations in this form where we have something times something equals 0. And then we just set each part equal to 0 like this and solve. Alright, let's take a look at the next one here. Notice this one's already in factored form. We have two chunks, so to speak. So again, I set each part equal to 0. Either 2n has to equal 0, or n plus 7 has to equal 0. Once again, I have to divide each side by 2 here, but I think you can see that then either n is going to be 0, or, spell or right, or n will equal negative 7. Okay? So those are ones that are already in factored form, but important that you see how those work before we go on. Alright, now we get into some that are a bit tougher, of course. Now, in each case, on the one on the left, this is a trinomial equal to 0. You would have no clue how to do this unless you knew how to factor. So again, whenever we factor, we always look for common factors. I don't see any in these three terms. So then I make my two sets of parentheses, and I do my FOIL in reverse. So it's probably going to be x and x. And a couple numbers that I know that will multiply together to give me 36 are 9 and 4. And looking at that signage here, since my middle term is negative, I'm going to make that 9 the negative and this the positive. And I think this would work out if I checked it out. But again, this is equaling 0. So now this is saying that either x minus 9 equals 0, or x plus 4 equals 0. So, again, we know in this case then that x is either going to be 9 or x will be negative 4. Okay? So there's our first case where we actually had to factor, and then we got it in a similar situation to what we did on the last slide, just set each part equal to 0. Alright? Now notice the next one here is not equal to 0. So that would be your first task. Make sure that your polynomial always equals 0. So you notice in this case I have to add 144 to each side so I get it to equal 0. Now, can I factor this left part? Yeah, I can. Again, I don't see any common factors, so I make my two sets of parentheses here. It's obviously going to be a and a. Now, if I think of 144, that's a big number, but actually you may remember or know that 12 times 12 is 144. And because my middle term is negative, it's actually going to be this. So this is actually a perfect square trinomial, a minus 12 times a minus 12. So all I have to do is set one of those then equal to 0. And sure enough, then A is going to equal 12. So here's a case that only has one particular answer. More examples here. These are the last two that we'll do. These are kind of the tricky ones, but always good to tackle something a little bit tricky, I think. Now, again, our first step here is we'd like to get everything equal to 0. So I do that first by subtracting 15k on each side, like that, equaling 0. Now, looky what we have here. Remember, we've always harped on looking for common factors. Sure enough, that's what we have here. Each of these terms has a k in common. So I factor that out, and when I do, then I have one less k in the parentheses here. All right, and sure enough, I can further factor what's in parentheses, I bet. So then I have k and k here. Again, a common way of getting negative 15 would be 5 and 3. So I bet it's going to be plus 5 minus 3. Again, you might have some trial and error with that. Now, what we have here that we haven't seen before, now I actually have three things multiplied together that equals 0. So again, I have to set all three of them equal to 0. So either k equals 0, k plus 5 equals 0, or k minus 3 equals 0. So my final answers then, of course, are going to be 0, negative 5, or positive 3. So how about that? So that's using an extra dose of factoring to try to figure those out. All right, and my last one here is sort of the same type of thing. Do you see any common factors here? Yeah, they each have an r. So then I am going to be left with 4r squared minus 9. Can I factor what's in parentheses? Yes, in fact, you may remember this as a special form, factored form. This is going to be one of these difference of squares. So I'm going to actually get 2r minus 3 times 2r plus 3. And once again, I said each part equal to 0. I'll just do one of these parts since I'm kind of running out of room here. So if 2r minus 3 equals 0, I'm going to do a little mental math here. That means I'm going to add 3 to each side. 2r equals 3. Divide by 2, and so r equals 3 over 2, or 1.5. Now we could do that same thing with this term. In fact, we should set it equal to 0. I think you can see in that case we're going to then get r equals negative 3 over 2. And don't forget about my last little guy here, that r that I have factored out or pulled out, I also have to set that equal to 0 too. And of course, that's just my common sense answer here, r equals 0. So we'll practice on these quite a bit in class. Thanks for hanging in there and getting these down in your notes. So we'll see you guys then. Bye now.